This is the fourth and final part of my review of the prerequisite skills that you need in order to be successful in AP Calculus. If you were paying careful attention on part 3, I said that that was actually going to be the third and final part, but part 3 ran long and I had to make a part 4. So here we go. In part 4, we will be analyzing rational functions like this one. We'll be looking for any holes and horizontal and vertical asymptotes. Let's start by simplifying as much as we can. So we factor the numerator using the difference of two squares pattern, x plus 3, x minus 3. The denominator has a common factor of 3x. So we're left with 3x times x minus 3. Notice that we have a factor in the numerator and in the denominator. When you have a factor that will cancel out the way these will, that's where holes come from. If I were to take this and set it equal to 0, I get x is equal to 3. That is the x value of my hole. So I'm going to have a hole at 3 comma something. Now it's just a matter of what will the y value be. To figure out what the y value is, go ahead and look at what's left of the function if you were to cancel out the x minus 3's. So that would leave you with x plus 3 over 3x. So this is what we will use to get the y value. So the y value is going to equal x plus 3 over 3x. We will simply go ahead and plug in the 3, substitute 3 for these x's. So that's going to give us, well, let's just do it mentally. So we have 3 plus 3, so that's going to be 6, and 3 times 3, so that's going to be over 9. So of course this will reduce down to 2 over 3. So we have a hole at 3 comma 2 over 3. The horizontal asymptotes, let me do the vertical asymptotes first. The vertical asymptotes come from the denominator. So the factor of x minus 3, that already gave us a hole. So that cannot be a vertical asymptote as well. It's a hole. So ignore the x minus 3. But the 3x will give us a vertical asymptote. All right, so I will get my vertical asymptote by setting the denominator equal to 0. So if I take 3x and I set that equal to 0, then I get x equals 0. That is my vertical asymptote. So x equals 0. Whoops, I wrote it in the wrong place, didn't I? So x is equal to 0. Now for the horizontal asymptote. The horizontal asymptote comes from the end behavior as x approaches infinity. So I'm going to look for my horizontal asymptote now, but in my mind what I'm doing is I'm doing end behavior. Okay, I'm thinking about the end behavior. I am going to use the simplified version of the function that I got after we canceled out the x minus 3. So I'm going to look at this version of the function right here. So imagine, as we talk about the end behavior, this is going to approach, okay, I'm asking myself what matters most. So in the numerator, as we approach infinity, this term and this term will be the only terms that matter. This little plus 3 hanging on the end, as this x becomes 1,000,000, and in the bottom we have 3,000,000. The little plus 3 is really not doing anything. So this is going to approach x over 3x, which in turn simplifies down to 1/3, right? Once you cancel out those x's. So the end behavior is that we're approaching a y value of 1/3. So that is the horizontal asymptote. Y equals 1/3. Okay, I think that's all we had to do for problem number 25. Let's do this again. I think we're going to need to factor the denominator on problem number 26. So there's nothing we can do with the numerator right now, so I'm just going to leave my 2x minus 1 hanging out up there. Let's see if we can factor this denominator. It looks like a pretty beefy one, but let's play around with it. 8x squared. There's a couple different ways this could go, but let's start with 2x and 4x. And then the 5, okay, I know 5 can only factor as 1 times 5. Now, I could have put the 5 here and the 1 here. But to be honest with you, I'm keeping an eye on the numerator. It's very common that things will cancel out, and I see that we have 2x minus 1 up there. I'm kind of betting, oh, it's 2x plus 1 actually. So I'm kind of betting that we're going to have a 2x plus 1 down here as well. So that's why I'm making this guess right away. Now, does this work out? Inner plus outer must equal the middle. Inner, I have 4x, all right? I'm multiplying these two. Outer, I have 10x. I'm multiplying these two. Together, that would make 14. So this checks out and we factored correctly. Now, as I mentioned on the previous problem, when you have the same factor in the numerator and the denominator, all right, a factor that will cancel out, that's where wholes come from. So we're definitely going to have a whole if we were to set this equal to 0. So if I take my 2x plus 1 is equal to 0, then that's going to give me x is equal to negative 1/2. So that is the x value of the whole. So I have negative 1/2 comma something. Now I need to find the y value. Well, the y value is going to be what we get if we plug in the x value into what's left of the function after you cancel out the 2x plus 1s. So if I take this, and now I know that my x value is negative 1/2, so my y value is going to be 1 over 4 times negative 1/2 plus 5. Okay, this will give me the y value. So what is this? So I've got 1 over 4 times negative 1/2 is negative 2. All right, so I've got y is equal to 1/3. So that is the y coordinate of my whole. Okay, so we have a whole at negative 1/2 comma 1/3. Now let's talk about vertical asymptotes and horizontal asymptotes. Remember that the vertical asymptotes will come from the denominator. All right, you will not look at the whole anymore. The 2x plus 1 will not give us a vertical asymptote because that's where the whole came from. You're not going to have a whole and a vertical asymptote. It's one or the other. So if you have the two that sort of cancel each other out, that is a whole. The remaining factor in the denominator is this 4x plus 5. This is where my vertical asymptote will come from. So my vertical asymptote is going to come from setting 4x plus 5 equal to 0. So that's going to give me x is equal to negative 5 over 4. So that is my vertical asymptote. So I will write x is equal to negative 5/4. The horizontal asymptotes, if there are any, come from the end behavior of the function. And for the end behavior, you can definitely use the surviving part of the function after you cancel out the factor that leads to the whole. So for the end behavior, g of x is going to be approaching 1 over 4x plus 5. Okay, now what matters most? In the denominator, this 5 is not going to matter as we approach infinity. So as x approaches infinity, all that's going to matter is this 4x. So g of x is going to approach, it's going to approach 1 over 4x. I'm disregarding the 5. So, but as x approaches infinity, or negative infinity, think about what's going to happen. The denominator gets bigger and bigger and bigger and bigger. So we have 1 over 100, 1 over a million, 1 over a billion. So what's happening is the overall value of the fraction is getting smaller and smaller and smaller. So this is actually approaching 0. So that is my horizontal asymptote, will be y equals 0. All right, that's all we needed for problem number 26. Okay, number 27. So we are really reviewing hard. Here we have the sum of two cubes. So you have to have memorized the pattern for the sum of two cubes. And it works like this. Maybe I'll just do it right here. You can factor the sum of two cubes or the difference of two cubes, and it really works the same way. The main thing is you have to remember that it will factor as a binomial and then a trinomial. The binomial is just going to be the cube root of each of these separately. So the binomial will just be x plus 2. Now, what about the trinomial? For the trinomial, I'm really going to be looking at the two terms in the binomial. I'm going to square both of these, and that will give me the beginning and the end. So I'm going to have x squared, and then I'm going to have plus 4. I simply squared each of these. That's how I got the first and the last term. That just leaves the middle term of the trinomial. The middle term of the trinomial will come from the product of these. All right, I'm going to take these and I'm going to multiply them together. So that's going to give me 2x. Now you notice I didn't put a sign down yet. And that's because I wanted to remind you of the acronym SOAP, which reminds us of how the signs go. Compared to the original sum or difference, the signs here and here and here will follow the SOAP pattern. Okay, S-O-A-P. This stands for same, opposite, and always positive. So because we had a plus in the original problem, then in the binomial I have a plus because that's the same. But then right here it's going to be the opposite. So I'm going to put a minus 2. And then this final sign is always positive. So we have the acronym SOAP. Same, opposite, always positive. So there we just reviewed how to factor the sum of two cubes, and it would work the same way if this was the difference of two cubes. But you do have to remember that forever. In the denominator, we have the difference of two squares. So this will factor as x plus 2 times x minus 2. So again, we have this same factor in the numerator and the denominator. This will lead to a hole in the graph. So there will be a hole. If I set this equal to 0 and solve, I will get negative 2. So I'm going to have a hole at negative 2 comma something. I need the y value of the hole. So the y value, I'm going to go ahead and use the rest of the function. So I've got the negative 2, so I'm going to do negative 2 squared minus 2 times negative 2 plus 4 over negative 2 minus 2. All of this will give me the y value. So this is going to be 4 plus 4 plus 4. Interesting. And this is going to be negative 4 down here. So that's going to give me 12 over negative 4, which is negative 3. So we will have a hole at negative 2 comma negative 3. By the way, bonus points to anyone who recognizes that ringtone you just heard. Anyways, time to find the horizontal asymptotes. So the horizontal asymptotes will happen when you have end behavior that's approaching a constant. So let's examine the end behavior of this remaining portion of the graph, the remaining portion of this function. So h of x will approach all of this. I'm just going to recopy it. It's going to approach x squared minus 2x plus 4 over x minus 2. We can definitely ignore the x plus 2's that cancel out as we approach infinity, because we're nowhere near the hole, which is the only thing that we have to worry about. Now we can ask ourselves what matters most in the numerator and in the denominator. In the numerator, this is the term that matters most. We can ignore the rest. In the denominator, this is the term that matters most. So h of x will approach x squared over x as we approach infinity. Of course, this simplifies down to just x. So as x approaches infinity, obviously this approaches infinity. So there will be no horizontal asymptote because it's just going to approach positive infinity and negative infinity. Vertical asymptotes come from the denominator, and we will ignore the part of the denominator that gave us the hole. So that leaves us with the x minus 2. If we set that equal to 0, that gives us a vertical asymptote of x equals 2. All right, last one, problem number 28. The numerator will not factor because it is the sum of two squares, not the difference of two squares. So we will have to leave the numerator alone, x squared plus 1. The denominator is the difference of two cubes, which we saw on problem number 27. So remember that the difference of two cubes will factor as a binomial and then a trinomial. The binomial is just the cube root of each term, so it's just going to be x minus 1 for the binomial. If I take each of these terms and square them, that will give me the beginning and end of the trinomial. So if I square x, of course, I'm just going to have x squared. If I square negative 1, that's going to be positive 1. That just leaves the middle term. The middle term will be the product of these two. So 1 times x is just x. The sign is always going to be the opposite of this, though. So this is going to be positive right there. All right, so we factored it. In this case, there is nothing that will cancel. So there will not be any holes. So let's go ahead and just write none, because there are no holes, because there are no factors that can cancel. Let's talk about the vertical asymptote. So the vertical asymptote comes from the denominator. I'm really only going to consider this part right here because this trinomial, not only will it not factor, but it doesn't have any real solutions. If you try to set this equal to 0 and solve it, you'd have to use the quadratic formula and you would end up with imaginary solutions. Like that's almost how it always works when you factor using the sum or difference of two cubes. So I'm going to ignore the trinomial and just do the binomial. Setting that equal to 0, that gives me x equals 1 for my vertical asymptote. For my horizontal asymptote, it's actually going to be easier for me if I use the original unfactored form. Because I can think about what matters most. As x approaches infinity, j of x approaches, well, it approaches whatever matters most. So in the numerator, the x squared is the only term that's really going to matter. It's going to absolutely dwarf the plus 1 that's hanging out there. And in the denominator, all that matters is the x to the third power. So j of x will approach x squared over x to the third power, which simplifies to 1 over x. So as x approaches infinity, or negative infinity for that matter, what's going to happen to the value of this expression? Well, as the denominator gets bigger and bigger and bigger and bigger, the overall value of the fraction is getting smaller and smaller and smaller and smaller. So we'll just imagine that we have 1 over 100, 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000. This is getting microscopically small, and in fact it is approaching 0. So that is the horizontal asymptote, y equals 0.